Hi, I'm going to explain question 8 of exercise 4k. So reminder that our lesson is about solving simultaneous equations using graphical techniques. So you will expect to sketch two or more. In this question is two straight line and see where this point of intersection is. Okay, so we're going to do that using the given information. So our given information include that these two equations or these two asteroids are 1,000 kilometers apart. Okay, so before that, let's explain this a bit. We are talking about speed. So we should have this x-axis here as 10 and this vertical axis is going to be distance. This is because we are given speed. And if we take distance divided by 10, we're going to have the speed. And if we want to use the speed as gradient, we should set up our Cartesian plane this way. So times in the horizontal axis and distance on the vertical axis. Okay, so again, they are 1,000 kilometers apart. So I know if I choose the reference of the first point to be at 0, 0 at the same time, the other one will be 1,000 kilometers apart, which is over here. Okay, so that's the idea. That's the direction that I'm going to go. Now, we got two different speeds, 59 and 41 kilometers per second. So again, if we're going to use these as gradient, we can imagine that if we have two lines with two different gradients, they will meet if the steeper one starts from down here. Okay, so they go steeper and steeper, and the other one with lower gradient start from this point, and with lower gradient, eventually if you sketch those two lines, they will meet somewhere here. So that's the direction. So now we know that's how it's going to go. So we have a clear idea of how we're going to sketch the two lines. Then we can actually sketch them. So keep in mind, this is going to be the astronaut with the gradient, which is this speed, 59 kilometer per hour. And the second one is here, 41 kilometer per hour is this one because it has lower gradient. And that one I would choose that to be the one that starting from this point instead of this point. You can swap them to the other way around, but it'll be much harder. Like you're gonna need a larger Cartesian plan to draw those two lines. Okay, so this is the easiest way. So based on that information, we just work it out as usual. So for this asteroid, which is traveling off with the gradient 59 there at 0, time is equal to 0, distance will be 0. As the term that it's equal, now I wouldn't say 1 because my scale is different. I would say 10. At 10 seconds, we work it out. The distance going to be 590, so around here. Okay, and at time equal 20, again, it's going to be somewhere here. So we plot like that. Imagine if the line is not there. Okay, so we plot as usual in this sort of scale. We do 10, 20, 30, and so on. Okay, just fill point and then connect the line to make a straight line. And we will do the same for this one. Again, this one, the gradient is 41, but keep in mind we choose it. It has to be 1,000 kilometers apart, so it's gonna have y-intercept at 1,000. So the equation for this line will be d equal 41 t plus 1,000. Sorry, it's a bit messy. It's not easy to write on the computer. Okay, so this is 41. Yep, and that's the equation. So we do the same. We plot the point. So at t equals 0, the distance is 1,000. So we have that point here. Again, at t equal 10, we're going to have distance at 1,410, so it's around here. So we plot a few more points. At t equal 20, we got another point here. We plot, and then we end up with these two lines. Okay. Now, with the big scale like this, we can only estimate the point where it's meet. I actually typed these two equations in this one, and the first one was d equal 50 90. I actually typed these two equations onto decimal to get these two lines, and the point of intersection is when t equal 55.5 recur. So it's around 56 seconds. Round up to the nearest second, around 56 seconds they will collide. Alright, hope this helped.